Hello, my name is Jesús Torralba. I am a PhD student in Geomatics Engineering in the Geoenvironmental Cartography and Remote Sensing group at the Polytechnic University of Valencia, Spain. I have participated in the MaiL project as a secondee, and in the three next videos we will talk about the indicator that will identify the degree of land marginality, we will review the processing of the dataset, and we will do a practical exercise. So, in this first slide, we will see the definition of the soft constraints. In the context of the MaiL project, the soft constraints are the indicators used to analyze the degree of marginality of a land area with non-thematic data. For this purpose, we studied 17 indicators related to terrain and soil, such as slope, depth available to rock, texture, clay, sand, or total available water. Other indicators related to soil sustainability were soil acidity, soil erosion, flooding, toxicity contamination, natural toxicity, and dryness. And also some indicators related to productivity, including soil organic matter, capture sink capacity, and grassland or forest productivity. In the left margin of this slide, you can see the workflow that we had followed in the section and that we will review point by point. The first step to determining the indicator that constitutes the soft constraint is to carry out a literature review based on studies specifically focused on methodological aspects of marginal land mapping. As a tip, in the literature review, we need to pay attention to the minimum cartographic unit or spatial resolution of the layer they use, the technology used to make the dataset, the indicator of marginality they use, and the threshold of the indicators with which marginality is nominated in each study. The second step is to define, based on the literature, the maximum and minimum threshold for each indicator. This threshold refers to the range of value that a given indicator could reach. Once we have identified the maximum and minimum value of the indicator threshold, we divide it into three ranges. The first range, with a score of 10, represents the best value of the indicator, for example, productive lands. The second range, with a score of 5, represents the average value of the indicator, not very fertile and not very productive land. And the third range, with a score of 1, represents the restrictive value of the indicator, land potentiality unsustainable or incompatible with any activity or management. As a tip, in the case of finding more than one threshold in the literature, the threshold can be set on the maximum and minimum value for the study area. For example, in MaiL we choose the value for whole Europe. During this phase, we must make sure that each indicator has a dataset for the study area. Consequently, if an indicator cannot be matched to a dataset, it is appropriate to evaluate whether to omit the indicator. The third step is to analyze the importance of the soft indicator, and for this purpose, the indicators are classified and ordered according to the number of times they appear in the literature. Once the indicators are ordered, the Pérez comparison matrix (PCM) of the ranks is calculated following the method proposed by Zolekar and Bahan 2015. After that, the PCM is normalized and a weight is obtained for each indicator. To normalize the values, each PCM values is divided by the sum of the values in each column, and then the weights for each indicator are calculated using the average of the values in each row. These weights are scaled 0 to 1 in ascending order to preserve the area according to the importance in the marginality, and the sum is equal to 1. Finally, we will obtain a table like this one. In this case, this is the summary table of the soft indicator using the MaiL project methodology. Also, here we can only see 9 of the 17 indicators, and the rest I will show you in the next slides. You can see the layer name and the measurement unit, and the threshold defined in the literature. Threshold based on refers to the scientific publication from which the threshold was obtained. Source refers to the repository from which the data was freely downloaded. Rank refers to the position in which each indicator appears in the bibliography ranking. Weight refers to the weights obtained in a normalized PCN. Score refers to the value given to each of the threshold in order to categorize them according to their marginality. And then you can see that the dataset with two weights were the indicator with information from topsoil and subsoil, and they were treated as independent indicators. These tables have been copied from the publication we presented at the CIGEO Congress. In this slide, you can see the rest of the indicator with the same structure. Here are the documents that have been cited during the presentation, and I highlight the document where you will find the complete methodology. Thank you, and see you in the next video.